Alright, here we are going to learn how to use the graphing calculator to, first off, just graph parabolas, but then find vertices and find solutions. So, previously we've learned how to factor to find solutions, how to use the quadratic formula to find solutions. Now we're going to use the graphing calculator, which actually, for a lot of you, will be a lot easier. I know I find it a lot easier because I don't actually have to rely on my math skills so much. I really just have to rely on my resourcefulness and interpreting what the calculator is telling me. That's really the important part, that I know how to use the calculator, I know actually how to use that resource, plus I actually know what the calculator is saying to me. That's the most important part. If you can't understand what a resource is telling you, then you really don't know how to use that resource at all. So, before we jump into all of that, I'm just going to go over how to use the graphing calculator to graph it. So you want to hit y equals. So you should see that screen. You hit y equals in the top left, and now we can type in that equation, x squared minus 4. And that's going to tell us what that parabola really looks like. So it looks like a right side up u because the leading coefficient is a positive. But it's kind of tough to tell where those points are hitting because it's so pixelated, so I'm going to use the table to actually figure out these points. And I'm going to graph at least 3, and when I say at least, I really mean at least. Sometimes you need more than that. I'm going to see those points here. Actually, I'm going to graph those 4. -2, 0, -1, -3, 1, 2, 3, 0, -4, and then 1, 3, and I know that it's going to be symmetric. So I also know that 2, 0 is there. I can actually check to make sure, but I know that for a fact that it will be symmetric. So that's my U shape. I'm not going to be able to do this perfectly, but I'm going to actually complete that U shape by connecting those dots. That's what my parabola looks like. So here I'm going to be also talking about what the vertex is. The vertex is always the top or the bottom point. And it really just depends on the shape. If it has a top, then it's the top. If it has a bottom, then it's the bottom. Here, it doesn't really have a top. It goes off forever. On the left side and the right side, it does not have a top point. But it does have a bottom point, and we found that with these coordinates. That 0, -4 is what we call the vertex of that graph. It's where the graph really starts turning around. It's going down, coming down this way, and then it pivots and goes back up. That is the vertex of the graph. In this case, it's the lowest point, or what we're going to start calling the minimum. It's the lowest that gets down to. And we're actually seeing these as ordered pairs. We're talking about the x and the y value that are associated with it. If we want to find that without a graph, if we want to find it just algebraically, we can use that equation. The x value is described by -b divided by 2a. So here, in that equation, I'm going to write this a little bit differently. Y equals x squared. There is no b, so I'm going to write that as plus 0x minus 4. Really, it's not that there's no b, it's that the b equals 0. So I'm going to substitute that in for b, and substitute in a, which is just 1. But that's pretty uneventful because 0 divided by anything is just 0. That equation only tells me the x value that I have. Now I take that x value, and I'm going to plug it into that equation. So I'm going to take that x value, x equals 0, and substitute it in. So y equals 0 squared minus 4. 0 squared is just 0, and 0 minus 4 is -4, which confirms what I thought in the first place, that my x is 0, my y is -4, and that set of coordinates is actually my vertex. Actually, since we're on a roll with that, let's just continue doing that using this equation, that -b all divided by 2a. I'm going to find the vertex. So maybe let's label the b And the A is negative 1/2, B is negative 2. So negative B is negative negative 2 divided by 2 times negative 1/2. That's my A. I'm going to simplify this a little bit. Basically, it's like negative 1 times negative 2, or positive 2. And it's 2 times a negative 1/2, which is a negative 1, which tells me that my x is going to be negative 2. So that is my vertex, or at least the x-coordinate for my vertex. Now I'm going to find the y value for that vertex. So I'm looking for y, which means I'm going to take negative 2 and plug it in. Negative 1/2 times negative 2 squared. Please don't forget to put parentheses around just the number. The exponent is on the outside, the negative sign is on the inside, the number negative 2 goes in parentheses, everything else is on the outside. And now I'm going to follow order of operations by squaring that as my first step. So I have negative 1/2 times 4 minus 2 times negative 2 plus 2. I have some multiplication that I have to do. I'm going to multiply negative 1/2 times 4, which is negative 2, plus this. That gets multiplied. Negative 2 times negative 2 changes into a positive 4 and plus 4. Excuse me. And now I'm just going to simplify that. That gives me a positive 4. So I have my vertex. In this case, that's negative 2, comma 4. And actually, that's going to be one of the points on this line. Sorry, on this curve. Negative 2, 4. The reason I'm correcting myself when I say line is line actually implies that it's straight. So these actually aren't lines, they're curves, or parabolas if you want to be really specific. But that's one of the points on there, and actually it's going to be the top point. So I see that my number in front of the x squared, my leading coefficient, is negative. So I know that it's going to be an upside down parabola. So I have one of my points on there. I can plug in some other numbers and find the rest of them, or I can use the calculator. So I'm going to do that since it's a little bit easier. Negative 1/2 x squared minus 2x plus 2. I'll look at the graph to confirm that that looks at least roughly right. It looks like my vertex is negative 2, 4, but I can't really tell what those other points are, so I'm going to look at the table. So negative 2, 4, actually you can see it right there. That's good confirmation that I did something right. And then I have some other points. I always want to pick easy points to graph. So I'll use a 0. Actually, let me use the y-intercept also. 0, 2. Negative 4, 2 is another easy one. And let's scroll up to see where this thing, where that thing hits the, oh, no, I don't have a 0 listed there. That means it's going to be a decimal. All right, well, I actually have a clear enough picture from just that. I know it's going to look roughly like that. I'd like to know my zeros, but we're going to find out how to find that in 2 seconds. We're actually going to talk about how to find a solution using the graphing calculator, but it's not totally apparent from that list of coordinates. So my vertex here, it's not my lowest point anymore. It's actually the top point. It's the highest point. And we call that the maximum. It's the biggest x value, excuse me, it's the biggest y value we have. It's the highest that that graph actually gets up to. So the vertex could be the top or the bottom. It kind of just depends on the shape.